Hello friends, today we will discuss about classification metrics with examples and there are different matrices which are used for various algorithms, and this one is for classification algorithms. So as you can see, there are five we shall discuss in here. First is accuracy, confusion matrix, classification report. You've got ROC or receiver operating characteristics and log loss. So let's get started. Now, where does this metric come into picture? Now, we've got this algorithm to train our model. All right, we trained our model. Now, what next? We get some accuracy. This model gives us some accuracy, okay? And this accuracy means that how good my model can predict on an unseen data. So now what happens is I got my accuracy. What after that? Now, I want to evaluate the performance of my algorithm itself. Okay, so for that we have got this matrices. This is algorithm. Okay, so the matrices selection is what happens here is that we measure the performance of the algorithm, how good it is, right? Is it giving me the good accuracy? This helps us to select the best algorithm for our data, and then we can further go on with it. And also it helps to understand the importance of various characteristics we have in the results. And as we've seen that this is a way to evaluate the algorithms, right? Which is the best algorithm, we choose it, we select it, and then further we go on with that algorithm for our model. Now, first is the classification accuracy. This is the most common evaluation matrices for classification problems. Now what happened here is, you look at this formula, that how it has been calculated. This is calculated by taking account of, or I can say the ratio of correct predictions divided by the total predictions. Okay, so how does it work? Let's see with an example. This is the IRIS dataset accuracy, and I fitted this model using support vector machines. Now let's just focus on this accuracy part, 0.93. How do we get this? This is the confusion matrix. We shall discuss it later. But you just see this is 7, 10, and 11. So there were three classes to classify in iris flower: Setosa, versicolor, and virginica. So for the first instance, we've got 7 right. For the second, we've got 10 right. And for the third one, we've got 11 right. Now, how our classification accuracy works. This will add 7 plus 10 plus 11, which is 28, divided by the total number of observations. So 7 plus 10 plus 11 plus 2, because all these are 0, divided by 30. So 28 divided by 30 will give you 0.933. So accuracy is 93%. Okay, so this is how we calculate the accuracy. Now let's come to the disadvantages of accuracy. Actually, accuracy works when we have a balanced data set. That means equal number of classes for each data. It is working well with the balanced data set. For example, the iris data. Now, this is not true when we work with real life data set, and we get always the imbalanced data. Okay, so accuracy is not a reliable measure. That's why we have got different matrices for calculating the algorithm's performance, or you can say the efficiency. Now, this is not suitable for regressions also, regression problems. Now, what happens, the another disadvantage is here is that it only measures the overall correctness. It will not tell you the false positive and the false negative error. Okay, if you look here, it will not, it is just telling me the correctness, that how correct my data is, but it will not tell me anything about the false or the errors. Okay, so next, that's why we come on to the next matrix, which is logarithmic loss or log loss. Now again, this is used for evaluating the predictions of probabilities of a given class. Okay, now what happens here is the predictions which are correct or incorrect, accordingly they are being rewarded or they are being punished. If it is correct, then it is rewarded, and if it is incorrect, then it is punished. So now suppose this is log loss, so the smaller the log, the better it is. If it is 0, that means we've got perfect log loss, and the probability should be between 0 and 1. That's what probability is between. Okay, so it reduces the entire gamut of predictions into 0 and 1, and it predicts it, okay, and tells you what is the loss or what is the error. Okay, next is ROC, that is receiver operating characteristics. Now this is used for binary classification problems. Okay, binary means 2. Now the area under the ROC curve, it represents the model's ability so that it can distinguish between the positive and the negative class. And you can see this graph that this is also plotted against true positive rate and false positive rate. Okay, true and negative classes, positive and negative classes. The it is created by positive by as we have seen this. Now the area of 1, if I get this entire area as 1, this means that my model has made all predictions perfectly. Okay, and if I get area as, let's suppose, 0.5, that means that it is fine, it is making fine predictions, but it is not accurate. It is not making all the predictions perfectly, but it is making only few predictions which are maybe correct and few predictions may be wrong. So that means I have to improve upon my algorithm if that is the case. So RSC is a good measure when it comes to, for classification matrices. So in the next video we shall discuss about classification report and the confusion matrix. Okay, and thank you and stay tuned.